name is JR Perrott, and I am the owner at Extreme Turbo Systems. We primarily make turbocharger kits for import vehicles, mainly what we consider sport compact. That is any Japanese imported vehicle with a turbocharger that is basically $50,000 and less. We make everything from a intake system that will add 20 horsepower to a car to a whole turbo kit that could add 400 or 500 horsepower to a car. All these items are manufactured domestically at our facility, Vancouver, Washington, and that's what we do with the cars. The Turbo Collector project was basically a project to prove to us that the additive manufacturing could produce a product that we could put on a vehicle and run in a real-world situation. Typically, when we come up with a new idea or a new product, we have to model it, and then we print it in plastic, and then we build hard tooling to end up casting it. The additive manufacturing allows us to go straight from computer model to basically printed product that we can run on a vehicle. Because our products are part of a exhaust system of a vehicle, the temperatures are extreme, typically up to 15 to 1600 degrees Fahrenheit, and it is what's considered a very harsh environment with a lot of vibration and a lot of heat and a lot of thermal cycling, where the items can be glowing red hot and then get drenched in water. So metal fatigue is a major issue, and we wanted to prove that a piece that was manufactured through additive manufacturing would hold up to those conditions. So what we ended up doing was printing what's called a merge collector, which is the part of an exhaust system where all of the exhaust gases from each cylinder of an engine come together before entering the turbocharger. This is typically the hottest part of the system. When you see it in real-world conditions, the piece will be glowing a bright yellow to almost white. If there is a part of the system that breaks, it is in the collector area. So we felt it would be a good idea to print a merge collector and see if it would hold up, because if it did hold up within a real-world test, we feel confident enough we could print almost any other piece within a turbocharger system. Yes, we were skeptical. I wasn't sure if it would work, because I had heard of some other products that had been 3D printed, and when they were put into a turbo system in the harsh environment, they simply crumbled away. So we have a vision for down the road to be able to print other components within this system, but we wanted to prove to ourselves first that the pieces would hold up. So we were skeptical at first, but it seems to have held up. The process actually went very smooth, because I guess there were two things we were skeptical of. One was we were skeptical of if the 3D printed item would hold up, and two is that we gave MTI a hand-fabricated piece, and we wanted to see if they could replicate within thousandths of an inch a hand-fabricated piece. So what we gave to MTI was basically not out of a computer. So it has a lot of flaws in it that are hard to reproduce because it's hand-fabricated. They were able to scan that. They then imported it into their CAD system, cleaned it up, and then printed the actual item that we would run. They eliminated the steps of printing plastic models and the steps of building tooling to end up with a cast stainless piece. I believe the cost of the collector would be around $5,000. The cheapest I could see us getting to this same piece through conventional methods would be $15,000. The main cost in there is the tooling for the casting. For us, what it means, more importantly than the dollars, is the time. Normally, to get from a hand-fabricated piece to a cast piece ready for prototype is at the fastest a month, but typically 1 to 2 months. And with the MTI process, it could be easily within 2 weeks or less. So we get from idea to prototype, and more importantly, a testable prototype in a very short amount of time. Well, when it first arrived back, we were pretty impressed because ultimately it's an item that had just been, printed out of metal. So, of course, it looked correct. Our only skepticism would be if it would weld. Because when we weld, normally you will see any impurities in the metal come to the surface per se. So really on the appearance of the product, we were impressed with it. I mean, it was clean, it was nice, and it was hard to believe it just came out of a printer. But the bigger deal for us is could we weld it to other pieces of material? And we were able to weld it successfully to other components. The merge collector is a component of an exhaust manifold. And so the merge collector is kind of the heart of the exhaust manifold. So when we got the merge collector back, we had to weld it into the exhaust manifold. So we had other pipes and tubes we were welding to it. So one is we were able to successfully weld it. From there, we installed it on an actual vehicle that gets driven every day. And that may not sound as harsh of an environment as like a race car or whatnot, but it's actually worse because of the thermal cycles. So what we were skeptical of is, one, would the 3D printed piece simply just deteriorate? And two is, would the weld hold up? And we were mainly worried about the weld because we were unsure of how pure the alloy was in the 3D printed piece. At this point, the car's been on the road for about 4 months, gets driven daily, gets heat cycled daily, and in the Pacific Northwest, with the rain, it's an extremely hard environment because under the hood, the piece is glowing, but then during a rain, it gets hit directly with water. Bottom line is, if we see failures, they normally happen within the first week to a month. So this has been on the road for 4 months. So far, it looks promising. For future designs, we now have the confidence to implement this technology into a much more complex design. And so instead of a $5,000 item that would normally be $15,000, we wanted to use this as a stepping stone into maybe what would normally be a $80,000 item that should only cost us $20,000. And we have the confidence to go into those projects with this process. The big problem for us in business is getting one from idea to tested prototype. We can get from prototype to production pretty quickly, but it's getting from idea to tested prototype, which is a confirmed working item. And this cuts our timeline into about a third. So on top of saving us money, it gets us to where we know we're moving ahead with that product that much sooner, which in turn gets it to production sooner, which then starts the revenue stream. I've never had a bad experience with MTI. They do what they say they're going to do, and they do it very accurately. When we design things, we have a matrix of about half computer-generated designs and then just half hand-built. And one of the hardest things in industry is to take something that's hand-built, digitize it, and get it to production. And that was the other thing that MTI was very good at, was they replicated a hand-built piece. I mean, they literally could use this to reprint sculpted art if they wanted to, which typically is very hard to do.